Alright, let's talk a little bit about vectors. We're going to use vectors a whole lot in class, and as we went over in class, vectors are basically arrows that we can use to describe things that have a direction. So we got vector A, B, C, and D, and we're looking at how we can put them together, how we can add them or subtract them or break them down. So let's just start off with A and B. It's pretty simply. So if we talk about A and B, they're going in the same direction. Obviously B is a little bit longer than A, right? So if I look at my ruler, got A is about 1 inch, B is about 1.5 inches. And so if I take A, let's see if I do this. If we did vector A, this little hat thing is what represents a vector. Sometimes I'll write it, but most of the time I just leave it off for some reason. I shouldn't, but that's my bad. Anyway, vector A plus vector B is going to equal something. And so if we say, hey, vector A, let's just say that's about 1. Vector B is about 1.5. Well, if they're going in the same direction, vector A and vector B put together should be about 2.5, right? And that's just kind of common sense. We got, hey, two things going in the same direction, just stack them on top of each other. And so I'd say, hey, we got vector A, and we just stack it on top of vector B. Kind of like that. And so we get something that would be 2.5 long in total. Now, it didn't matter whether I stuck vector A on top or vector B on the bottom. I can switch them up. I still get 2.5. But you guys have been doing this all your life. This is just adding, okay? And if I said, hey, what about vector A minus vector B, then what is that? And so if I took 1, and what is subtraction? Subtraction is just addition, adding the opposite. Let me turn this music down just a little bit. So I've got 1 going in the positive direction here. Let's just say like this. And I'm adding the negative b. Negative b is going to be going down 1.5 the other way. So something like that. And what I get in the end is just this little piece over here. And make it a different color. Make it pink. Alright. So I get this little piece over here. That would be vector A minus B, whatever that is. And so here's 1, here's 1.5, and so 1 minus 1.5 should give me 0.5 right there, and that's what it is. All right, so 0.5, and it would be in the negative direction. And so whenever we write an equation, that's where we use negatives. Here we can see which way it's going. That's not that big of a deal. So adding and subtracting vectors, it's basically working on the number line, you know. But what if we had vector A and vector C? And vector C is essentially the same thing as vector A, except it's not going up, it's going to the right. So what if I said, hey, let's take A and let's add it to C? You know, and you might say, well, A is 1 and C is 1, so A being 1 and C being 1, let's just add it together. That might be 2. But if we look at it, if we add the arrows like we should, I take vector A here, which is 1, and I take vector C here, it's going to the right, and that's 1. Well, the result, in other words, the resultant vector of these two put together should be going up and to the right and have properties of the things that make it up. Alright, so this vector over here, this is called the resultant. And the resultant has a magnitude or a length of its own. It has a direction of its own, and we can see that it's it's not 1. It's actually a little bit longer than 1. And so the way that we figure that out is we can do Pythagorean Theorem. And if you already know what the answer is, then well, that's what we're about to get. We're just going to take 1 squared plus 1 squared and then square root it, and that's going to give me the square root of 2. Okay, that's the resultant, and square root of 2 is bigger than 1. All right. That's what we get for the result of A plus the square root, or A plus C is going to be the square root of 2. Now, that's not good enough because the square root of 2 obviously is not going in the upwards direction. It's not going in the right direction. It's going up and to the right. And so we need to figure out this angle here. And, you know, just by logic, we see that this is one side is the same as the other side. So this is a 45, 45, 90 triangle. So this will be the square root of 2 at 45 degrees, and to be very, very specific, let's just say this upwards is north, downwards is south, east is to the right, and west is to the left. we're going to say 45 degrees east of north. And what I mean by this is that we're going to reference north, which is straight up, and we're angling 45 degrees to the east of that. All right, so this is going to be the most specific we can be for this vector's length and its direction. All right, now we can talk about vector A and B and C and D together, but let's go ahead and just talk about, well, what if we did C and D added? So let me move this over just a little bit. And so we can see that C, let's just do vector C plus vector D. You know, vector D, that is 1 as well. So C plus D must be 2, right? But we just saw that, you know, A plus C, 1 and 1, does not make 2. It makes square root of 2 here because we're not on one number line, we're on 2. So C and D, if we were to draw it out, this is the, again, a tail to tip method. I'm going to draw one vector. This is vector C. Pen didn't work out too well. And that's 1. And vector D was going up and to the right. Looked like it was about 45 degrees. I didn't really write it down up here. Let's just say, hey, that's 45 degrees. So here's vector D, and it's 1 long at 45 degrees above the horizontal. Now, what's the result of this? It's not 2. The result of this is actually going to be what you get from the beginning all the way to the end, like so. And so our question is, hey, what is that? And you might say, oh, well, you know, it's 1 and 1, and all we got to do is we got to say, oh, 1 squared plus 1 squared square root is going to be the square root of 2, right? But obviously, no, that's not. So the Pythagorean theorem doesn't really work here. It works with right triangles, but it doesn't work with this one unless we make it some sort of right triangle. And if you look at the pink line, it's the hypotenuse to its own right triangle. It's the hypotenuse to this one. Okay, so our job has got to be to figure out what the long side is, this whole side here, and this side, because those are the sides to my unknown hypotenuse. That's what I want. So we've got 1 right here. We're going to have to add that to whatever this is, one of these legs of this diagonal piece right here. So, you know, if you got a 45, 45, 90 triangle with 1 over there, then you might already know what the sides are, but let's go ahead and go through the traditional steps. So we don't know what, let's call this x is. We don't know what y is. But we do know this whole side has got to be 1 plus x. This whole side over here is just y. And so we're looking for x or y. They're the same thing, so we can just focus on one of them. Let's say we want this side. And we're going to use some trigonometry because it's not always going to be 45 degrees. But what is side x compared to my angle? And I'm going to see that side x is actually adjacent to my angle. I have the hypotenuse here. And if we know about SOHCAHTOA, then this is screaming at us that we're going to use cosine. Because SOHCAHTOA helps you figure out whether you use the sine function, the cosine function, or the tangent function. Each function gives you the ratio of two sides. And we just said, hey, we're talking about the x side, that's going to be adjacent. We're talking about the hypotenuse, and that's going to be cosine. Okay, if we talked about side y, that would be opposite, and hypotenuse, and that would be sine. And if we just talked about sides x and y, that would be opposite and adjacent to my angle, and that would be tangent. All right, so right now we've talked about x, and so that side adjacent to my angle, it's touching it, and we have the hypotenuse, that's the longest side, and that's going to say, hey, let's go to cosine. So I'm going to write down cosine, and it's cosine of 45 degrees. And that equals the ratio of two sides, side adjacent x over the side that is the hypotenuse. And so all I need to do is take the cosine of 45, and the cosine of 45 degrees, make sure you're in degree mode, is 0.707. That's going to come up a lot in your lives, I think. So x is equal to 0.707 and something else. Because this is a 45, 45, 90 triangle, y is also 0.707. And so for the long side here, we've got 1.707, and this side is going to be 0.707, and so now we can find out what the question mark is. How long is that? That's going to be the Pythagorean theorem of 1.707 squared plus 0.707 squared, and then square rooted. And that's going to give me, let's see, 0.707 squared plus 1.707 squared, and then I'm going to square root, I get 1.85. Hopefully that's right. 1.85, and let's use one more. I already rounded it. All right. So this whole side is 1.7. 1.8 is longer than that. 0.707. I think we're good. So this side here is 1.85, but of course we got to give it a direction. Let's find that angle right inside there. And so to find the angle, I'm going to use these other things called the inverses. I'm going to talk about tangent to the inverse. And all I'm going to do here is I'm going to say second tangent. It's going to pull this up in my calculator, and I need to plug in the two sides that are associated with tangent. And SOHCAHTOA says that the tangent is equal to opposite over adjacent. That's what I'm going to work with. So tangent inverse is going to be opposite. What's opposite this angle? It's going to be this side here, because I'm working with the big right triangle. And this side is 0.707. And then adjacent is going to be this whole side here. It's touching the angle. 1.707. And inverse tangent of 0.707 over 1.707 gives me about 22.5 degrees. And to be very, very specific again, we were talking about, we can say counterclockwise. From the positive x-axis. Another thing we can do is we can say it's going to be 22.5 degrees north of east if we use traditional cardinal directions. All right, so just a quick run through there. That's a simple part, all right? And what if we get a little bit more complex? What if we take all these vectors and we add them all together? All right, so what if I went all the way over here? Let's move over here. Let's see if I can have some room. What if I said I want to do A plus B plus C plus D? Okay? And so if I said A plus B plus C plus D, all these vectors put together, then what I'd end up with is something that goes up, something that goes up again, something that goes to the right, and something that goes more up and to the right. So overall, something's going to go up and to the right a whole lot. Okay, and if you were to draw this out, we might do something like this. It would go up, that's vector A, B is 1.5 long, C is over here, see how I'm doing these tail to tip, and then D is going to be somewhere up here, top of my page, and A, B, C, and here's D. And then our resultant would go from the beginning all the way to the end. That's what's going to account for all this stuff. Okay? And so, how do I figure this out? Well, you might think to yourself, well, I got to figure out this angle in here. This might be important. I got to figure out, well, that's a 90 degree, and then this is going to be some weird triangle. Well, make it easier on yourselves, okay, guys. Let's just say, hey, this, I know we're going into the other picture here, but can't really help it. This, okay, you see that right there? You see that triangle? That's what we want. So we got to find out this side down here, we got to find out this side up here, and all we need to do is we just need to look at, what's our total in the y, what's our total in the x. And so if I do A plus B plus C plus D, we only work with one number line at a time. And so I want to do AX plus BX plus CX plus DX. Okay? That's what I want to do. So AX, there is no X component to A, right? That's nothing. Plus BX, again, it just goes straight up, so 0. Plus CX was 1, right? It goes 1 inch to the right. And then DX, this is the only weird one right there. dx was the one that went up at 45 degrees, so we got to figure out the side, and it was 0.707. Remember this one down here we have in our paper. Down here, this side was the component that goes to the 1 at 45 degrees, so it's 0.707. 0.707. So the total that I have going to the right in the x direction is 1.707. I guess inches in this case. And then we look at the y directions. And again, we're making this very easy on ourselves by just looking at x's and then looking at y's. So AY is, well, it's 1. BY was 1.5. CY, there's no CY, it just goes to the right. And then DY is this side here. Remember, it's 45, 45, 90, so it was 0.707. And so if we just look at this, we have 1.5 plus 1 is going to give me 2.5, and then 2.5 plus 0.707, let's see, 2.5 plus 0.707, what does that give us? It's like 3.207, yeah? Kind of late. Good stuff. So the total in the x is this, the total in the y is this, and so I'll cover all this stuff up. So the total to the right we went was 1.707. We can double check my ruler. The total we went to the right is 1.707. That's about right. And then the total up that we went was 3.2, and that's going to be right about there, and that's exactly right. So this whole side is 3.2. And so to find this side, we need to take the Pythagorean theorem of these two component sides that make it up. And so I'm going to take 1.707, and we're going to square it, plus 3.207, and we're going to square that, and we're going to square root this. It's going to be 3.63. So this side is 3.63 units long, and then to give a direction, then we need to work with the inverse tangent of the side opposite. That's going to be the y side, 3.207, divided by the adjacent, 1.707, and 3.207 over 1.707 gives me 62 degrees. 62 degrees, and that's going to be north of east. And I'm kind of scrunching everything in here, but hopefully we got that all together. So if you have a bunch of vectors, yeah, you can put them all together like this, but really what you want to do is you want to break them up. You want to just look at the x's, just look at the y's, and that's going to make your world a lot easier in a lot of these problems. Close this one up. Have a good night.